Hello students, welcome to Shorus's classes. This video is the mathematics segment of the economics entrances, came in 2016. It's a compilation. I will be solving this question now. This one is actual statistics based question, and the student wishes to regress household food consumption on the household income. This is an interesting fun fact that household is not equal to consumer. There is a basic difference. For example, in general, a consumer means one. A household is a group of persons, okay, whose economic conditions are interdependent. But here, the household is considered to be a one person's personal decision. So household food consumption and household income. By mistake, the student regressed household income on the household food consumption. So A on B, B on Y. So, and found capital R square is 0.35. So what is the correct R square regression of the household food consumption on the household income? So in case of reverse part, regression with the reverse of Y on X, if we just proceed, R square remain the same in both the cases. So write it here: if independent and dependent variables like y equal to 7x square plus 9x plus 3. So here x is the independent variable and y is the dependent if we change positions. Then also if x equal to function of x, we write so function of y. So here also the pattern will not be changing. And one important thing, remember that SST, sum square total, minus sum square residual sum square is equal to SST. This is also called sum square between YSST, and this is equal to capital R square. So the answer is 0.35. Now proceeding to the next question. This question says about some extremum value. Let f equal to r square to r. So two-dimensional to one-dimensional formational change is defined by this function. This one is a nonlinear function. Then which of the following statement is true? So which of the following statement is true? X equal to 1, y equal to 0 is a local maxima, x equal to 1, y equal to 0 is a local minima, or neither maxima nor minima. So here a very important structure. What is the difference between local versus global max or mean? Okay, let me draw a diagram here. If it is like this, now if we consider this area, do it by a different color so that it will be easier for you to understand. If we consider this much area, then this point is the minimum point. Okay, I have to redraw it. So if we consider this much area, this is the maximum and this is the minimum. If we take another interval like this, then this is the maximum and this is the minimum. Now these all are called on a particular interval a1 to b1, a2 to b2. So these are all called sub intervals. So these are all called sub intervals, not the entire one. So these are all called local extremum, EXTREMUM. So that means local maxima or local minima. If we consider the entire one from this to that area, then it gives you with respect to the entire domain. So the entire domain gives you the value of global maxima or global minima. Now here we are proceeding with the question. Now let me solve this one. So what is del f del x? the partial derivative. So this is 3 into e to the power y minus 3x square equal to 0. And del f del y is 3 into x into e to the power y minus 3 into e to the power 3y equal to 0. So solving these two, we get x equal to 1 and y equal to 0. Next part is f of xx, that is minus 6x, f of xy, that is 3 into e to the power y equal to f of yx by Young's theorem. And f of yy is 3 into x into e to the power y minus 9 into e to the power 3y, 9 into e to the power 3y. So simply the determinant here will be fxx, fxy, fyx, fyy. So just put the values over here, minus 6, 3, 3 and minus 6. This gives you 27, which is a positive number. So coming back to the question here. So simply this is positive, so it's a local minima. So x equal to 1 and y equal to 0 gives you local minimum. So that's all for this video. In the next video we will explain some more questions from the PG standard. Thank you.